A fellow train enthusiast contacted me through my YouTube channel, and he wanted me to design something and print something for him on my 3D printer for his O-scale engines. And what it was this winterization hatch for on top of a Lionel F unit, like an F7. And I didn't have one of the engines, so he sent me this sample, which was an HO scale sample, and said, you know, design something up like that. But I didn't know if it was going to fit on his engine. I didn't have an engine, and I said, take some cardboard or some cereal box or something like that and cut it up, measure it out, and make me a sample that sits on top of your engine with the correct arc and the general size you want, and then we'll just use the HO1 as a model. So he sent me this green piece here. Gives me dimensions of what he thinks will fit and the arc that he has marked there for over top of the diesel engine. Then I used that to design this first piece here on my 3D printer. It was just a first iteration to get everything right. Of course, when you print things on a 3D printer, you have to print them. You can't print like in midair, you know, so you'd have to have supports and stuff like that. So I had to print it that side down. And of course, this little hatch over here couldn't stand proud of the top. So I'd have to print it in two pieces with the grill separate and then insert it later so that it would stick up through the top. These little tabs here I put on for gluing surfaces in the corner. But again, I don't know if it will fit, so he'll have to try it. I printed this one, has a little burned filament there. And I printed another one where I eased the edges over on the top with a fillet. I made the arch higher here, bigger here to match his. And then this last one, of course, I made the hole, the tolerance of the hole bigger so that these little grill pieces fit inside there from the bottom up. And he should be able to just drop it in there and glue it in. Now, if he doesn't want to use that, he can get some little metal screen or something like that, but that's the tightest I could go. It was 0.1 millimeter height, and I couldn't put the holes any closer together. You know, the nozzle is 0.4 millimeters when it prints, so you have to have some material there. It can't print smaller than the nozzle is for the 3D printing. So he'll have to take it and test it and let me know if anything needs adjusted, and then I'll print some for him. The rest of this video, I'll go through some of my design process and the 3D design process, which led me to print these on the 3D printer. So I'll come up here and I'll begin by creating a sketch on the plane here. I'll just do a 2-point rectangle. And I used my calipers to get the measurements off of his sample. So it was like 27 millimeters by about 32 millimeters. Got the general shape here. Then I'll just extrude it up. And I measured it to about 12.5 millimeters. So we have our basic shape for starting. Now what I'll do is I'll shell out the inside, and you just pick the surface that you want to cut out. It'll create a shell. I'll shell to the inside by 1.6 millimeters. That'll make my wall 1.6 millimeters wide, and the outside dimensions won't change. Now what I need to do is cut a hole in the top for the grill to be inserted. So I'll just start out by putting a rectangle here on a plane, and I measured it to be about 5.6 by 18 millimeters. What I can do is dimension this up so I can say exactly how far I want it from each edge, which is really nice. It'll be 4.5 millimeters from each edge. And I just choose the sketch, and I will extrude it to, and instead of picking 1.6 millimeters, something like that, I'll pick the whole under surface. That way if I ever modify it, it'll change dynamically. It'll just cut right through there, and there we go. There's our notch cut out. Pretty nice. So now what I'll do is I'll just ease the 4 edges on top a bit. I'll grab these 4 edges here, and I'll do a fillet. And I'll do it at about 1.2 millimeters because that's a factor of my 0.4 millimeter nozzle width. Now there's a seam that goes down the edge, the left and right edge of this thing. So what I'm going to do is make a 45-degree chamfer right in the center. So I'll just start out by creating some lines here to give me some guidance. Okay, I'll make one through the center here. And actually, I think what I'll do is I'll just make a rectangle here that I can extrude out. That'll work pretty good. Make it 0.8. And then I'll just grab the rectangle and bring that out 0.8 as well. So that'll be a nice multiple. And we probably should, yeah, then we'll just chamfer those two edges by 0.8 and see what happens. There's just a little seam down there. It's just a little detail. There's nothing structural about it. It's just the original has that. It's for looks. And we'll give that a shot. Might be a little small when we go to print it, but we'll adjust it later. Now I have to put that seam on the other side too, so I'll mirror it. But what am I going to mirror it about? Well, I will mirror it about a center plane. So there I made a mid plane between the two sides, which is pretty cool, that yellow plane in the middle there. Then I can just do mirror, and I want to mirror which faces, that and that. And I'll mirror it about this center plane. And there we go. We can see that they were created on the other side. So that's a pretty cool way of doing that. Turn off the plane. I should probably make some glue tags or surfaces so that some super glue will hold. So what I'll do is I'll make a sketch. Okay, I'll make some construction lines that will help me for mirroring these things. Because I'll make one up in the corner and then I'll just mirror four of them. Okay, so I'll make these two lines through the center as construction lines. And I'll just draw one. And I'll make it 2 millimeters square. See how that goes. Then what we'll do is mirror this one. So mirror these 4 segments. Mirror it against this line. See how it puts it on the right there. So now I have one on the left and the right. And now I'll just do another mirror. And I'll mirror these 2 top. And now mirror it against the line here. And now we got 4 of them. We should be able to just choose them and extrude them up. Should be able to extrude them up to the top surface here. Tool body creation failed. I've seen that before. I think I can just grab it and bring it up to the, it's like 10.9 millimeters. There we go. That'll work. Now we need to cut the arc at the bottom edge here. So as usual, I'll start on a surface by making myself some guidelines, some construction lines. So I'll make one in the center here. Then I'll create another one. And I'll let the computer do the work for me. I can't guarantee I have it in the center. So pick that, make it a construction line. And then I'll just dimension it. One millimeter from the bottom. That will be the height of my arc. Then I'll make a 3-point arc. I'll pick left side, right side, and then the center point. There we go. That's going to be my arc. Might be a little small, but we can always increase the arc later. So looking at the front here, I just choose that face and I can extrude it the whole way through to the other side. And because it's gone through the body that's turned on, the red indicates it'll cut it out. So there I've actually cut my arc. Pretty nice. Now I printed a sample and realized that some changes needed made. So I need to ease these edges a little more. So I'll go back here and I'll edit this fillet that I put in, and instead of 1.2, I'll make it 2.4. The edges are now rounded over more. And as I suspected, the gap at the bottom here, the curved arc, just is not enough. So I need to increase that. So what I should be able to do is grab that line. Oh yeah, it's 1 millimeter, so I'll just make it 1.6, which is a nice multiple. Make that arc just a little more. There we go. When I made this little seam in the left and right sides, I thought it wasn't going to stick out enough. I think I did it like a 0.8 millimeter. So now I'm going to go back here and edit that and increase that up. So if I edit the sketch, I can make the rectangle now 1.2, a multiple of 0.4, my nozzle height. Okay, stop sketch. I can extrude it out to 1.2 instead of 0.8. And then I should be able to chamfer and mirror to 1.2. There we go. The errors went away. I got the mirror. So that should be a little more pronounced. Okay. Now this will require a little effort. I want to make an insert for this grill. So what I'm going to have to do is create an offset plane just arbitrarily up here a little bit so that I can project the opening in the top up onto that plane and use that to design my grill insert. So now I'll go on that plane and I'll project these 4 lines up. Okay, see how the purple lines are now projected up onto that plane. Okay, cool. Now I'll select these 4 and I'll do an offset because I want to make minus 0.8. I want to make it like bigger by 0.8 so that when I insert it from the bottom it catches. It has like a little lip, little catch inside the hole, and they can just glue it in there. See how it overlaps there. Now the original has a metal grill, but I want to try to simulate the grill pattern in plastic just in case we want to use it. So I have to start getting set up to do that pattern. So I'll just do some lines here, center point lines, construction lines. I'll make this blue line midpoint on there. And then make these 2 lines construction lines. They're dotted now. I got to work out some kind of a pattern that simulates the grill. I'll just do like a hexagon and try to get it straightened out here. 0.4. Then select it and do a rectangular pattern. And I figured out ahead of time if I symmetrically make like 17 of them, they'll line up here with some space between them. I don't know how they're going to print, but you got to start somewhere. And now I have to pattern these 17 holes vertically. I'll make 5 rows of them. Now this will make a really nice pattern. Actually, what I'll find out later is these holes are way too small to print or print around them. You don't print the holes, but we'll talk about that later. Now what I can do is extrude this up. So I'll just pick everything that isn't the holes in the grill and I'll extrude it up. I figure 3.4, and then I have to turn the sketch back on, take the lip over here, and I'll bring that up. That'll give me like 1 millimeter, something like that, to catch underneath. And 2.4 minus the 1.6 body wall height. It'll just stand up a little through the top. Now we'll turn the other body component on. We can see both of the components now. Now because we have two components, we can make a joint. So we'll say make a joint from this point here. It's hard to get. We want to put that point and join it to, come on, very touchy, to this point here. Cool. Got a rigid joint. Now let's go back and see what it looks like. Sweet. So this shows a lot less holes in here. I printed it, and because this thing is so small, I couldn't print that many around that many holes. So I had to reduce it here to 3 rows and I forget how many less holes horizontally. And lastly, amateur mistake. I forgot to consider my tolerances on the hole in the top. I made it the same size when I projected it up, and I should have made it maybe the hole bigger. So see, here it's 5.6. I'm going to make it 6.6. It's probably a little too much, but 0.5 millimeter probably work, but this is safe. And then this 18 wide, make it 19 wide. You can't, when you print stuff, you can't make it the same size. You got to allow for tolerance. And so we're back where we are at the beginning. I have these little insert grills. I have my piece we designed. We've had the tolerance correct now, and we can just insert this in here, glue it up, put it on the engine, paint it up, weather it, do what you have to do. So I'll have to send this out to my train bud, let him check it out and let me know how it fits, and then print them up some more. So I hope you liked this process and learned a little bit along the way. I just have some fun with it. Hope it's been entertaining for you. Thanks so much for watching.